Welcome to the MOOC lecture on the forebrain, Diencephalon. At the end of this presentation you should be able to state the location of the diencephalon, list the subdivisions of the diencephalon, describe the dorsal thalamus features, list the various groups of nuclei of thalamus and their functions, describe the hypothalamus and its important functions. Location of the diencephalon. It is located between the midbrain and the cerebrum, below the corpus callosum. Subdivisions of the diencephalon. The diencephalon is anatomically subdivided into the dorsal thalamus, metathalamus, epithalamus, subthalamus, and the hypothalamus. The dorsal thalamus, derived from the Greek meaning inner chamber. External features. It is a large egg-shaped nuclear mass. At the anterior end is the anterior thalamic tubercle. Posterior end is the pulvina. The right and left portions of the thalamus are joined by the interthalamic adhesion. The floor is formed by the hypothalamic sulcus. Nuclei of dorsal thalamus. There are three nuclear groups divided by the internal medullary lamina. They are the anterior nuclear group, medial nuclear group, and the lateral nuclear group. Functional subdivisions of dorsal thalamus. Nonspecific relay nuclei. They receive their afferents from the rhinencephalon and reticular formation of brainstem and project mainly to the hypothalamus and corpus striatum. They are the midline nuclear group, the intralaminar nuclear group, and the thalamic reticular nucleus. Association nuclei. These receive input from many converging sources and in turn project widely to the association areas of the cerebral cortex. These are the anterior nuclear group, medial nuclear group, and the dorsal tier of lateral nuclear group. Functional subdivisions of dorsal thalamus. Special relay nuclei. It is made up of the ventral anterior nucleus and the ventral intermediate nucleus. They receive information from the dentate nucleus, globus pallidus, and substantia nigra and relay that to the motor cortex. The ventral posterior nucleus. The ventral posteromedial nucleus of the thalamus receives fibers from the trigeminal nucleus and the taste fibers, while the ventral posterolateral nucleus receives information from the medial lemniscus and spinal lemniscus. They project first to the somatic sensory area via the central thalamic radiation. The metathalamus. As shown in the picture, they are the lateral geniculate body or nucleus, LGN or LGB, concerned with vision, and the medial geniculate body or nucleus, MGN or MGB, concerned with auditory information. Medial geniculate body acts as a relay station for audition, receives fibers from inferior colliculus, projects to auditory area via acoustic radiation. Lateral geniculate body acts as a relay station for vision. It receives fibers from the optic tract and projects to visual area via optic radiation. The epithalamus. It consists of the following: thalamic medullary striatum, habenular trigon, habenular commissure, pineal body, and posterior commissure. The epithalamus functions as a connection between the limbic system to other parts of the brain. Some functions of its components include the secretion of melatonin by the pineal gland, involved in circadian rhythms, and regulation of motor pathways and emotions. subthalamus. Position. Transition zone between diencephalons and tegmentum of midbrain. Content. Subthalamic nucleus, parts of red nucleus and substantia nigra. The subthalamus receives afferent connections from the substantia nigra and striatum and regulates skeletal muscle movements. The hypothalamus. It lies ventral, or below, the thalamus, derived from the Greek for under chamber. Boundaries. Superiorly, it is the hypothalamic sulcus. Inferiorly, it has the optic chiasma, tuber cinerum, infundibulum, and mammillary body. Anteriorly, it is bounded by lamina terminalis. Posterior, it continues with midbrain tegmentum. Subdivisions of the hypothalamus. It is divided into the preoptic region, supraoptic region, tuberal region, and mammillary region. Nuclei of hypothalamus. Supraoptic region. Supraoptic nucleus produce antidiuretic hormone, ADH, vasopressin. Paraventricular nucleus produce oxytocin. Tuberal region consists of infundibular nucleus, ventromedial nucleus, dorsomedial nucleus. Mammillary region consists of mammillary nucleus, posterior hypothalamic nucleus. The connections of hypothalamic nuclei. Supraoptic nucleus produces antidiuretic hormone, ADH, and via the supraoptical hypophyseal tract, it is stored in the posterior lobe of the pituitary, or hypophysis. Paraventricular nucleus produces oxytocin, and via the paraventricular hypophyseal tract, it is released and stored in the posterior lobe of the pituitary, or hypophysis. Particellular neurons in the arcuate nucleus and nearby region of the walls of the third ventricle secrete releasing and inhibiting hormones, travel along the tuberoinfundibular tract, via the portal vein of hypophysis, into anterior lobe of pituitary gland, hypophysis. Overall functions of the hypothalamus: autonomic control, endocrine control, temperature regulation, regulation of food and water intake, emotion and behavior, control of circadian rhythms. Thank you for watching the presentation. Your feedback on this presentation will be very valuable.